So this is question 1 from the 2025 Stage 2 SACE Physics exam. This is a really normal question 1. Question 1 doesn't always look like this, but it often does. So this is a projectile motion question. A golf ball was struck from ground height, giving the ball an initial speed of 27.0 meters a second at an angle of 55 degrees above horizontal, as shown in the diagram below. And we're ignoring air resistance. And we, in general, ignore air resistance unless they tell us otherwise. So A and B are, again, pretty normal starts to an exam. What we've got here are, these are show that questions. So a show that question, a reminder, it gives you the answer. You have to not use the answer in your calculation. You have to get to the answer yourself, but you can check that you've got the right answer because your answer should agree with their answer. So all we have to do is grab a formula sheet, and you can see on the formula sheet the formula for horizontal speed and vertical speed, just here. So again, the initial vertical speed is the initial problem. So I'm just going to use V sub V, theta V sine theta, which is equal to 27.0 times sine of 55. And you can tell it's going to get 22.1 meters a second. Same deal for the second one. V sub h is equal to V cosine theta, which is equal to 27.0 times cosine of 55, which is equal to 15.5 meters. Show that the golf ball reached its maximum height after 2.26 seconds. So if you look at the formula sheet, you think about the variables we know and stuff, and then try and find an equation that connects them. We know the acceleration due to gravity, I'm going to call it negative 9.80 meters a second. I'm going to call it negative because it's acting in the opposite direction to the initial velocity, like the initial vertical component of the velocity. We know at the top of its arc, V sub f, if you like, is 0 meters a second. And we know that V sub I, its initial vertical component of velocity, this is a vertical question because we're dealing with height. Its initial vertical component of velocity is up here, it was 22.1 meters a second. And we're trying to find S. No, we're trying to find T. Yeah. And so do we have an equation that connects A and V sub F and V sub I and T? You look, and obviously we can just use this equation here, right? So again, write down the equation. V sub F is equal to V sub I plus AT. We're rearranging for T, so we've got VF take VI all on A is equal to T. And let me check our numbers in. 0 take 22.1 and negative 9.8 times a scalar, so it's really important we end up with a positive number, and we will because we've got negative 22.1 on negative 9.8, and you can tell that works out to be 2.26 seconds. So this is why this is a show that question. We used our answer from A to solve C. The way SACE write exams, if that's ever a situation where, like, the question, to answer question C, you need an answer previously, they'll always be show that questions so that you're never stuck without the information you need. Last couple of bits. Question D says, determine the horizontal distance traveled by the ball while it's in the air. Well, we know that the ball was in the air for 2.26 seconds. We just saw that. We know that its horizontal component of velocity was 15.5 meters a second. That's question B, and it was a show that question again. And I want to find S. I've just called it V sub H, and I guess I could have just called it V. In the horizontal direction, in the absence of air resistance, there's no force, and so there's a constant speed. And so I can just use V av equal to S on T. Rearrange that to get S is equal to T V av. Chuck some numbers in, 2.26 times 15.5. Yeah. Hopefully that makes sense. So whatever, it's going to be 33 or 34 or something, somewhere around there. This kind of question, and indeed this question here, question C, these are both worth 2 marks. The 2 marks are effectively for choosing the right equation and getting a final answer. Same deal here. Picking the right equation is 1 mark. Actually using it and getting an answer is the other mark. I don't have a calculator to hand, but so maybe it's 34.2 or something meters. That's the other mark. The diagram below shows the path taken by the ball if air resistance is negligible. This is the initial assumption. On the diagram above, sketch the path taken by the golf ball if air resistance is not negligible. If air resistance is not negligible, there's going to be a force acting in the vertical direction to oppose its initial upwards motion. So it's going to not get as high because there's going to be a force opposing it. And there's a force acting against its horizontal motion as well. So this sketch is not going to be perfect, but it's going to not get as high and not travel as far. Air resistance does break the symmetry of the parabola, so it's not symmetrical around the maximum height anymore. And, you know, the key thing that SACE are looking for is that you've shown a reduction in the maximum height and a reduction in the maximum distance.